Hello, everyone. Good evening, good afternoon, or good morning from wherever you are joining us today. My name is Nadia, and welcome to a Microsoft Reactor livestream event. Today, I'll be joined by Nathan Rose, who is a lead consultant at Capgemini and a Microsoft MVP, specializing in Power Platform and Dynamics 365. Given it's the Rugby World Cup, Nathan is going to show us how to revolutionize rugby predictions using Azure AI and Power Platform. But before we kick off the session, I'd like to draw your attention to the Reactor Code of Conduct. In short, we want to ensure that this is an enjoyable event for all, so please ensure your comments are constructive and welcoming to all attendees. Throughout this session, you can send us your question in the chat and we'll try to answer as many as possible. Additional links will be added to the chat as well, including links to find out more information about how to be a community leader and be part of our MVP program. If you would like to reference back to today's session, you can do so on a Reactor YouTube channel. I'll share the link in our chat box. But now it's time to hand the floor over to our awesome speaker. Over to you, Nathan.
Thanks so much, Nadia. Good evening. Kia ora koutou katoa. Welcome to Revolutionizing Rugby Predictions with Azure AI and the Power Platform. As Nadia mentioned, I'm Nathan Rose. I'm a Microsoft MVP in business applications and lead consultant with Capgemini. I'm based here in beautiful and rugby mad Auckland, New Zealand. I work with the Power Platform, the customer engagement apps in Dynamics 365 and Azure every day. And I am incredibly passionate about using the Power Platform to solve difficult challenges for my clients and empower citizen developers. So tonight we're going to be talking all things Power Platform, all things rugby, all things data and AI. And in preparation for tonight's session, I took a selfie. This is something that we're increasingly seeing in our space, the melding of computing and statistics together, which makes me wish that I had paid a bit more attention to my stats course back at university. So as we get into the session, I'd love for these to be as interactive as possible. So if you have a question, a comment, something that you're not sure about, feel free to drop a comment in, and I'd love to interact with you and make this as interactive as possible. Now, a quick overview of our time together this evening. We'll start out with the big idea and get into what early search engines have in common with using AI sentiment analysis to predict match winners at the Rugby World Cup. We'll then get into the demo. We'll see how accurate the predictions have been for both the Women's Rugby World Cup last year and the Men's World Cup, which is going on right now. And then we'll wrap up with lessons learned and how you can incorporate those into Power Platform solutions that bring humans and AI together. So that's an overview of our time together this evening. So I'll give you a quick second to read this quote by Tim Berners-Lee. He's the academic widely credited with the invention of the World Wide Web. I absolutely love this quote. It makes me tremendously excited because this idea that we are increasingly only limited by our imaginations. We're seeing this now with low and no code tools. Everything you're going to see tonight is low and no code built in the Power Platform. And as we see the introduction of generative AI and tools like Copilot that Microsoft is starting to bring out, I believe we are only going to see exponential growth in connecting the previously unconnected, and we're going to see the limits of our imagination expand massively. So I absolutely love this quote from Tim Berners-Lee, and it really is the inspiration behind the thought bubble that I had last year. So last year I was in a one-to-one with my boss, and I had a thought bubble. I said, what if we could use Azure sentiment analysis to read the news and use that to predict match winners at the Women's Rugby World Cup, which was played here in Auckland last year? So I went away, put together a working prototype on the Power Platform in a week or so, and the rest is history. Here we all are. So what I've done is as I mentioned, I'm using Azure Sentiment Analysis to predict match winners, and there's actually a common thread between the demo that I'm going to take you through tonight and the early days of internet search. Now, some of you may be like me and old enough to remember the late 1990s, back when dinosaurs roamed the earth and Netscape Navigator constantly bugged you to download the real player. Back then, when we wanted to find something online, we went to a website called Yahoo. However, Yahoo wasn't a search engine as we know them today. Yahoo was actually a directory that was compiled by humans who trawled through websites, figured out what they were about, and then put them into Yahoo's classification model so that people could find them. While this was laborious, it worked reasonably well until the late 1990s, when the number of websites sites grew exponentially, and they were simply unable to keep up with this exponential growth in websites. So a couple of guys in at Stanford named Larry and Sergey had an idea. They said, well, what if instead of using humans to comb through all these websites and figure out what they're about, what if we just simply used a proxy? What if we looked at keywords and sites that they're linked to determine what the site's about and go from there? And the rest is history. Larry and Sergey made out fairly well for themselves. They made a few dollars, and the name of their company's become a verb. Now, you're probably wondering, what does all this have to do with the demo that I've signed up to see? What do Yahoo and Google have to do with using Azure sentiment to predict match winners at the Rugby World Cup? Well, effectively, traditional rugby prediction engines function in a similar method to the Yahoo directory from the late 1990s. They're compiled by individuals who comb through stats to figure out what should be weighted and included in a model and what shouldn't. And while they tend to be quite accurate, they can't keep up with the massive amount of data that is associated with a single rugby match. And generally speaking, these engines look at the head-to-head history of the teams who are competing in a given match. However, when you think about it, there is an exponential amount of data that's related to a single rugby fixture. You have the teams going head to head. You have the 22 players who dressed for the match on each side, and they've got data associated to them. You have a location where the match is being played. You have a date and time for the fixture and data points such as weather. Then you have spectators who have shown up to see it. So there is a massive amount of data that could potentially impact the outcome of a rugby match. So effectively what I've done is I'm using a proxy. I'm taking, I'm scanning news articles, running them through sentiment analysis in Azure, and using that to decide whether or not a team is likely to win the match. So the sentiment is simply acting like a proxy, much in the same way that keywords and linked sites did in the early days of Google search. So that's the connection between the demo you're about to see and the early days of search. Now, the app that I've created is based on some assumptions, three key assumptions. The first assumption is that AI analysis of news and social media posts is predictive. The second assumption is that the posts that I'm gathering via Bing and last year the Twitter API, we'll get into that in a bit, is was relevant to the tournament, the teams who are playing, and the specific match. And then finally, my assumption is that the language in the post is straightforward. That there's no nuance or subtext or high context language. Sentiment analysis doesn't do too well with things like sarcasm. It's something that all the humans in the room understand, but sentiment analysis tends not to grasp so well. So those are the assumptions of the demo that I'm about to take you through. Now, in terms of the solution components, these are the components that have gone into the demo you're going to see tonight. On the left-hand side of the screen, you can see that I've got my Power Platform components. So I'm running a model-driven app sitting on top of Dataverse in the Power Platform. I'm making quite a bit of use of Power Effects. I'm using a custom command as well as a number of calculated columns, and they do some pretty cool things, which I'll show you. And then Power Automate is doing the heavy lifting between Azure Cognitive Services and Dataverse and doing a number of the calculations and whatnot that I need to make the predictions. And then in Azure Cognitive Services, I'm using the Bing News API to find news articles relative to the teams playing one another and then running them through Azure Sentiment Analysis to get that sentiment score to fuel the prediction. Now, on the far right-hand side of the screen, you'll see that I've used the Twitter API in the past. I was able to use that for the Women's Rugby World Cup last year. However, in his wisdom, Elon's decided to charge $100 a month to access the Twitter API. So no tweets for me this year. And then in the bottom right-hand side of the screen, you'll see that I initially did try to use an API from Rapid API. It unfortunately didn't cooperate too well with Power Automate. However, that API did govern the data structure of the app that I'm going to take you through shortly. All right, so that brings us to the demo. So we're going to go through the model-driven app. We're going to go through some of the custom pages that I've put in, one of which was slightly controversial, and I'd be keen to hear anyone's feedback on that. We'll get into the data structure, take a look at the use of PowerFX. I'll show you how Power Automate is doing the heavy lifting between Azure and the app. And then we'll talk about Azure Cognitive Services, how sentiment works, and then the prediction methodology, and ultimately the business end of things. How accurate were the predictions? So I'm going to exit out of the presentation, and you should now be seeing the model-driven app. Now, the first thing you're probably thinking to yourself is, this doesn't look like any model-driven app I've ever seen before. And the reason for that is I'm using a custom page as my home screen on the model-driven app. Now, this was a bit of a controversial choice with some of my colleagues when I shared this last year. However, something that I've been doing over the past few years is really challenging myself to craft apps and experiences on the Power Platform that help the user, that tell the user how they're meant to use them without requiring extensive user training, which is traditionally how we've done things in business applications. Think for a second, who taught you how to use LinkedIn or Facebook? No one did. You sat down and the app was self-explanatory in terms of how you were meant to use it, which is what helped them scale the way they did. So now, again, we've traditionally relied on user training in the world of business applications, but imagine for a second you're deploying a model-driven app to an organization with high turnover. A user might be using an app for a few hours on a single shift, or they might use it for a few months. But within 12 months, 50% of the users will have turned over and left the organization. In a scenario like that, it simply isn't economic to spend an extensive amount of time training new users. They need to sit down at the app and be productive right away. So the app needs to tell them how they're meant to use it. So this is my first, albeit clumsy, attempt at trying this, to have an app that's somewhat self-explanatory. And so I've got commands here that take me to various parts of the app so I can get to tables. And so at this point now you see something that looks very much like a model-driven app you're used to working with. Now, in terms of the overall data model for the app, it's a fairly simple series of one-to-many relationships. When I first created this last year, my assumption was that I was going to use it once and then throw it away. However, I am using it again for another tournament, so there are some design considerations that I would do differently if I were building this again in terms of some of the data relationships. But it's, as I said, it's a series of one-to-many relationships, starting with a tournament. A tournament is made up of pools. A pool is made up of teams, and a team has fixtures assigned to them, both home and away. And then within the fixture, I've got a table called match data, and this is where I'm running my predictions from Azure Sentiment Analysis. So this is the stuff that's coming in from Azure. And then lastly, I have a table called Match Prediction History, which shows how the predictions have changed over time as match day approaches. So I have a flow that runs daily to generate these, and we'll get into that shortly. Now, in terms of the prediction methodology and what's coming from Azure, the I get each block of text coming from a news article generates a positive, neutral, and negative sentiment score. And I am summing this up here using some PowerFX calculated columns. So I'm using the neutral score as a base. I'm adding the positive sentiment and subtracting away the negative sentiment. And I'm then using a power effects column here to determine who the winner is. So I'm using a logical comparison between these columns and then placing the name of either the home or the away side, whoever has the highest sentiment score. Now I'll show you how these work, because something that I'm quite passionate about power effects and using it in model driven apps, and it lets me do some cool things with this column. So let me come over here to this other tab, and I'll just show you when I update these scores. So if it's tied, I get too close to call, while the while there's no sentiment analysis, it's going to say predicting winner, and then it will put in the name of the side with the highest sentiment score. So pretty cool feature in model driven apps. This feature is still in preview, but I believe it should be going GA in the not too distant future. So that the calculated columns with power effects in the model driven app. Now, in terms of generating the prediction, I mean, when I first created this app, my assumption was that users would go to a fixture. So I've got a demo one here, and they would manually run the prediction. So I'll show you how this works. When I first showed this to my colleagues last year, the first question I got was, so who's going to win the match overall? So I've changed it to run daily on all the teams, and I'll show you that flow, but I'll just quickly show you how a prediction gets generated. So this is a demo match. It doesn't have a match data row associated to it. So let's go ahead and generate one. So I'm going to click this. This is a Power Effects command. It's gone off to call Power Automate. One of the things that I really like about this is that I can put in custom messages to the user to let them know that something's going on, as well as allow them to auto disappear after a set time. So just a hallmark of good user design to let the user know something's going on. So you can see that's disappeared. Let's go ahead and refresh. Now we will get an in-app notification pop up. However, there is a slight delay from when those come through, but you can see this has gone and generated a match data row for us. So let's go in and take a look at our prediction. So this has gone and predicted that the that the Wallabies are going to beat the All Blacks in this fictional match that I've set up. So you can see I've got sentiment scores that have come through from based on Bing News articles related to both teams, and based on that, it's predicted that the Wallabies would beat the All Blacks in this fictional match. And then I've got my match data row that's reflecting all this prediction data so that I can see how it changes over time. And you can see we've just got our in-app notification. So again, hallmark of great user design is to let the user know something's happened. So that's the app. That's my use of Power Effects in it. Let's segue into Power Automate, and I'll show you what's going on behind the scenes to generate these predictions. Now, the first flow that I've got is my main worker flow, which runs daily. So this runs in the middle of the day, New Zealand time each day, as most of the matches in France are done by about 10 a.m. our time. So this just runs on a schedule, sets a number of variables that I'm going to need later in the flow, finds all of the unplayed fixtures, and then for each fixture, it's going to go and it's going to query Bing News for the home and the away side. So you can see that I'm joining the name of the team with Rugby World Cup 2023 and using that as my search parameter to query news articles via the Bing News API. That's going to go and return some news articles to me. So you can see that I've got some text here that I'm going to run through sentiment analysis. Now, you might notice that the count here is 5. The Bing connector in Power Automate defaults to 20 articles out of the box. However, when I set this up for the Women's World Cup last year, I noticed that much beyond 5 articles, I wasn't getting stuff that was particularly relevant. So I just set it to 5, and I've left it at that. So once I've got the news articles for both the home and the away sides in a given fixture, I then need to go and pass the text through sentiment analysis. And the way sentiment analysis works is it takes a block of text, it analyzes it on a sentence by sentence basis, and for each sentence, it assigns a numeric positive, neutral, and negative score to it. It then aggregates those scores and gives you an overall positive, neutral, and negative score for the block of text that it's analyzed, as well as a sentiment label. Now, I'm using the numeric scores in my predictions. I'm not using the sentiment labels. So once I've got my numeric scores, I stick them into an array variable and then add them up to become the scores that you see here in the model-driven app. So that's what's coming from Azure in that step. Then I flip a coin to determine whether or not to give me a random prediction. Um, Even is heads, odd is tails. Heads is home team's going to win, tails is away team's going to win. I then update the match data row with the predictions and generate a new history row. So that's what's going on behind the scenes to generate the predictions each day for each match that hasn't yet been played. Now, as I mentioned, one of the questions that I got when I first showed this to colleagues was, so who's going to win the match overall? And the way I decided to solve that was to simply take my hypothesis a little further, that sentiment analysis of news articles related to the teams is predictive. And what I decided to do was sum them up to create an overall sentiment score for, for the teams. And so what I'm doing is I've got another flow that runs a little later in the afternoon, and what this does is it lists all the teams that have not yet been eliminated from the tournament. So during pool play, it's running for all the teams. At the moment, it's just running for the 8 teams in the quarterfinals, and then it will be the 4 teams in the semifinals, and so on and so forth. And so what it's doing is it grabs the match data rows for their matches, sums up their sentiment scores, and then I decided to handicap this a bit because I was seeing some weird stuff with these aggregate sentiment scores for the teams. And so to handicap it, I'm adding in the teams' IRB ranking points, tournament points, and their points for versus points against. So you might have noticed if you go to the Rugby World Cup website that there's a points for versus points against, and that's simply points the team has scored, points scored against the team, and that's taken into consideration as well. So I'm using that to handicap things a bit, as without it, I was seeing some really weird stuff, and you're actually going to see that in a second. So once I've done that, I update the team with a updated sentiment score. If we come back here to our app and we go to the teams, I've got them listed here in terms of their sentiment score. And the first odd thing you're probably noticing is that the top 4 ranked
Hey Nathan, it's Nadia here. Not sure if you can hear me. You seem to have frozen. Don't worry, everyone. We'll be back in 1 second. Hey, Nathan, you're back.
That my internet connection dropped out.
That's okay, no worries. We are back, everybody.
Okay, sorry about that, everyone. My internet connection chose the worst possible time to drop out. Okay, so as I mentioned, I am generating these overall sentiment scores for the teams, and I'm using that to predict an overall tournament winner, as some of my colleagues asked me about. So I'll take you to the second custom page that I've got in my app. Just wait for this to load. Now, the first thing you're probably struck with is that this looks surprisingly like a 1980s video game, and you'd be absolutely right. So design is not quite my thing, something that I'm still working on. But what I wanted to do was generate a tournament bracket. Now, the next thing you've noticed is that these quarterfinals don't reflect reality. What I'm doing is I'm just taking the top 8 ranked teams, then generating quarterfinals, and ultimately the hypothesis is the team with the highest sentiment is the overall predicted winner. So at the moment, this runs every day at 2:15 at New Zealand time. And so as of today, we have the All Blacks predicted to play Argentina in the grand final. So we'll see if that actually eventuates. I don't keep a record of these. This just changes dynamically each day. Based on the women's tournament last year, it wasn't particularly predictive or useful, but it is a bit of fun just to see who has the highest sentiment and could potentially be predicted to win the overall tournament. Now, in um, in terms of sentiment score, that aggregate score isn't particularly predictive. It tends to be more predictive on a match by match basis. So that's the app. Those are the flows that are working behind the scenes. That's how the predictions get generated. Let's get to the business end of things and see how well these have actually performed over last year's Women's Rugby World Cup and the men's tournament, which is being played right now. So we'll get back to our presentation. Okay, so last year, the app was 42.3% accurate across all the matches played in the Women's Rugby World Cup. So you can see it was a bit of a mixed bag from week to week. It completely whiffed the semifinals and then went 50-50 for the final and bronze final. So that was its first time out. This was using both Bing News articles and social media data coming from Twitter. Let's take a look at how well it's doing this year in the men's tournament. So we've just finished pool play. We're about to go into the knockout rounds. And so far across the tournament, we've seen an uplift by about 10 percentage points. It's 52.5% accurate. Now, the key difference between last year and this year is that I am solely analyzing um, news articles that I've found via the Bing News API. I'm not using social media data as you now have to pay quite an exorbitant amount of money to access the Twitter API. So these are just based off of news articles. So we'll see how it does over the knockout rounds over the next few weeks. But the next question we need to ask is 52.5% good? Is that a good result? Well, Seth Godin likes to say, as compared to what? We need some measuring stick to look at this to say, is this actually a good result? So you might have noticed in the demo that I have a column on the match data called coin toss. And so what I've done is I've introduced this idea of flipping a coin to generate a random prediction to compare against what I'm predicting from Azure Sentiment. Because if we are equally or less accurate than flipping a coin, we might be wasting our time. So let's see how the coin toss is doing. Yikes. Now, before you all drop off the call in disgust, let me explain. Something is very, very, very wrong here. Now, the coin toss has been 85% accurate across the matches played to date in the pool rounds. When I dug into the details, what I noticed was that it was picking the home team most of the time. Now that's an interesting insight that the home side seems to win most of the pool matches, something that I'll definitely look into down the road. But what but I've got a bug in the way I was generating my coin toss. Effectively, I said, okay, I need heads or tails. So Power Automate will let me generate a random number. I'll generate a random number between 1 and 2. 1 is heads, 2 is tails. Heads is the home side's going to win, tails is the away side's going to win. And as you can see here, when I crafted it that way, I was it was predominantly predicting heads. Now even the most um, unscrupulous pit boss in Vegas would be would be eye rolling at this, saying, "Come on, man, at least try to make this look good." So what I've done is I've changed the methodology for the coin flip for the knockout rounds, and I'll show you how I've done that because I would expect to see a more even distribution between heads and tails. Let me just flick out of the presentation, and we'll go back to Power Automate. And so the way I am doing my coin toss is I'm generating a random number between 1 and 100,000 and then determining if the number is even or odd. And in order to prove to myself that this should be a better way of doing this, I ran this 1,000 times, and what I ended up with was 523 odds and or evens and 477 odds. So it looks like it is a more normal distribution between heads and tails. So we'll see how the coin flip does in the knockout rounds. So the coin toss kind of backfired on me a bit, but we'll see how it does in the knockout rounds. All right, so we've seen the app, we've seen how it's performed. Let's move on to the final part of tonight's presentation, and we'll look at what I've learned about AI and how humans intersect with it, and how we can use those learnings to craft better apps and experiences and unlock more value moving forward. So, I'll give you a second to read this quote by Steven Pinker. Steven's a cognitive scientist at Harvard. That makes him wicked smart. Now, this quote nails my experience working with AI and sentiment analysis on the head. This idea that the hard problems are easy and the easy problems are hard. Let me give you a quick example of this. Now, a few years ago, I first started playing with sentiment analysis in Azure. And one of my first ideas was this could be incredibly useful for helping our clients manage their email queues. Something that's quite common in business is that companies have email queues that their customers use to contact them. However, however, those queues are often inundated with emails coming in and the staff struggle to keep up with the volume. So imagine somebody emails in and they're all caps screaming mad. That email languishes in the queue until it's attended to. But what if it's somebody important? What if it is the CEO of our largest customer? We'd want to know about that. We'd want to be able to route that to someone who can triage it and sort it out immediately. So that was my original idea. Pass the text of the email through sentiment analysis. And if you've got a strong negative score, and based on the sender of the email, we know who it is, and we know that, hey, they're the CEO of our biggest customer, our largest supplier, or something like that, we need to escalate that immediately. So I started playing around with it. And in my early examples, I would send very simple sentence structures that I would expect to have a strong positive score. Nathan, I think your demo is great, that kind of thing. But what I was seeing in the sentiment analysis was that it was generating a negative score. And I couldn't quite figure it out. When I dug into the details, I noticed that there was a much bigger block of text that was being analyzed than what I had sent in the body of my email. When I dug into it, it turns out that what happens when you send email from your corporate account is the legal department appends a lengthy disclaimer with friendly, cuddly language threatening the recipient if they do anything untoward with the contents of that email. And so that's what was tipping my sentiment scores into the red. Okay, so the way I need to solve this is I simply need to analyze everything north of the valediction and ignore everything else. Now, for a human, that's easy. For AI, that's actually really hard. This is an example of the hard stuff being easy, the easy stuff being hard. So, something that you would think would be difficult, having a machine read an email and tell you whether the email was positive or negative, that's really easy. However, having the machine determine which part of that email is actually relevant and which parts of it should ignore is quite difficult. Whereas for a human, we can eyeball it immediately and determine what what we need to work what's relevant and what isn't. So that's what I mean when I say the hard stuff is easy and the easy stuff is hard. But does that mean we should just chuck AI out and move on? Absolutely not. The key to working with AI is to understand and leverage the strengths of what AI does well and what humans do well. And in a nutshell, AI shines in the areas where humans get bored. When vast quantities of data must be ingested and analyzed, when you're working with results that follow along linear and predictable patterns, when there's no nuance or subtext, and when you need to do things like pattern recognition. It's a well-known fact that AI is quite good at finding nasties in MRIs long before human radiologists ever do. So those kinds of tasks. However, humans are at our best in the places where AI is not so great. So when you need a creative solution, something that's nonlinear, relational problem solving, emotional labor, these kinds of tasks is where humans shine. When there's subtlety, nuance, or high contextual awareness. For example, if someone makes a sarcastic remark in a meeting, the humans in the room understand it, whereas sentiment analysis would completely miss it. Humans do quite well with handling results outside of an expected norm. We quickly go from plan A to B to Z, whereas AI and AI tends not to do that so well. I'll give you a quick example. In the 2008 financial crisis, quantitative hedge funds really struggled because the models kept trying to buy and sell shares when the market was going completely haywire, and whereas as funds that relied on humans did a little bit better in those scenarios because they were able to see that things were going a bit haywire. So that's what I mean when I talk about things like handling things outside of an expected norm. And then lastly, humans excel at ascribing meaning to the pattern. So AI can tell us what the pattern is, and then we determine what that means and whether or not it's important. And so this brings us to what I'm calling a better model for human and AI collaboration. When we're crafting apps and experiences on the Power Platform, we need to take into account the strengths of AI, the strengths of humans, and account for both. Basically, the opposite of what I did in the demo that I just showed you. In the demo I just showed you, I went purely with AI doing everything. And, and really what we need to be doing is crafting solutions where we're both able to bring our best to unlock tremendous value. Let me give you an example of that. So a couple of years ago, I bought my first house. Now, anyone who's ever bought a home before knows that it is an incredibly stressful and emotional time. You're parting with a massive sum of money, you're signing up for a decades long financial commitment, and to make matters worse, you have absolutely no idea what's going on. When you show up to your solicitor's office to sign documents, your solicitor is busy, they don't have time to hold your hand and take you through everything, but they speak to you quickly in a language you don't understand. You ask for clarification. They just repeat it to you even more impatiently. And you ask if you're getting a house at the end of all this and you sign, but you don't feel particularly good about it. But when you think about what a solicitor is doing during the sale and purchase of real estate, they're simply mechanically processing paperwork. That's all they're doing. Now, that's something that AI could easily handle. So what if we were able to design something where AI is handling that mechanical paperwork and it frees up the solicitor to do that emotional labor, to take their legal knowledge, their years of experience, and their humanity to shepherd me through the process, to listen and empathize and help me understand what's going on. I believe that that scenario would unlock tremendous value. People would be willing to pay quite a bit more for a service like that. And those are the kinds of things that designing solutions this way, leveraging AI and humans, allow us to do. So how do we get there? Now, admittedly, I created this slide last year before Copilots and ChatGPT were a thing, but effectively, we need to understand that designing 100% AI-driven solutions, like the prediction engine that I just took you through, isn't necessarily the best course of action. Instead, what we need to do is we need to assume that there's going to be interaction and intersection between AI and humans, and then design processes that leverage the strengths of both so that we can unlock value that we previously couldn't. So with that being said, let's give the app a performance review. Now, in terms of what went well, we were able to quickly create a working prototype based on a thought bubble without writing a single line of code. And that's pretty cool that we can do those kinds of things. Connect the previously unconnected without writing a line of code. Was able to rapidly ingest and analyze large quantities of text and generate sentiment scores and compute predictions to predict a winner. So all of that worked quite well. However, some of the stuff that I got wrong, firstly, the solution is entirely AI and automation based. Something that I could have done and something that I've learned through all of this is that I could have unlocked far more valuable predictions by combining AI and humans, having AI generate those sentiment scores, but then having a human determine what's relevant and what's predictive. Secondly, I haven't really done any baselining against either human expert predictions, and the coin toss has kind of backfired on me so far. So again, this year so far in the Men's World Cup, 47.5% of the predictions have not been correct. Is this good or bad? We don't really know. So that's something that I still need to work on and get right. And then finally, I'm guilty of what professional poker players would call resulting. It's this idea of we don't know if we were right for the right reasons or simply lucky. And that's because I'm not really able to do any relevance checking on the news articles that I'm running sentiment analysis on. It was something that I'd hoped to be able to look at using OpenAI on Azure for, but I simply ran out of time as I was prepping this. So again, we're guilty of resulting. So as we wrap things up, what do we really want? Well, ultimately, we want to be able to leverage the respective strengths of humans and AI to unlock value that gives us better stuff faster, to be able to allow humans to bring our full humanity, to do that emotional labor, to do that empathizing, while AI churns away and does the boring stuff in the background. And so that brings us to the end of our time together. We've taken a look at how we're increasingly only limited by our imaginations, and we're about to see this grow exponentially with things like copilots. I've taken you through the demo, how it performed and what I've learned from it, and how that's informed a better model for human and AI collaboration on the Power Platform. So thank you all so much for your time, and I'm happy to take some questions.
Awesome. Thank you, Nathan. That was such an interesting session. So thank you so much for delivering that.
Oh, my
I've
pleasure.
popped a note to pop questions in the chat box. I think you've answered them all, to be honest. If
Okay.
we do, if we do have any questions that come through, I will shoot them through to Nathan. I've also popped the links into our survey and also our Reactor YouTube channel, so you can come back and watch the recording as well. But other than that, we will see you all next time. A special thank you to Nathan again, and thank you all for joining. And we'll speak to you all soon. Bye for now.
Thanks so much, everyone.